This lesson discusses the intermediate value theorem. Now remember, we are talking about polynomial functions here, so as we talk about the intermediate value theorem, remember that these functions are polynomial functions. So the intermediate value theorem says something to this effect. Let's suppose that this x-coordinate right here is A, and this x-coordinate is B. And let's suppose that when x is B, I get this point here, and then when x is A, I get a point that's in this quadrant. So I have a point in the first quadrant, and I have a point in the fourth quadrant, okay? And I want you to notice that for this point, I want you to realize that when x is B, my y-coordinate is f of B, and it's positive because it's in that first quadrant. So f of B is positive, right? Okay, and over here, when I look at x as A, this point will be A f of A, and notice that my y-coordinate here is negative because it's in the fourth quadrant. So my y-coordinate is positive here, my y-coordinate is negative here. Okay. Now remember, we're dealing with a polynomial function, so it has to be a continuous curve, right? So at some point, do y'all see that to get from this point to that point, it's got to cross the x-axis? And so remember, wherever a graph crosses the x-axis, that's the zero. That's the zero of the function. Okay. So the intermediate value theorem says this: if in an interval from A to B, if when x is A, your y-coordinate is, let's say, negative, and for B, your y-coordinate is positive, then there's some point C between A and B where you're going to get a zero, So in other words, f of C must equal 0. So there's some point where the graph's going to have to cross the x-axis. So basically, if you have an interval from A to B, and the y-coordinates are opposite signs, one's positive, one's negative, then the graph has to cross the x-axis in that interval at least once. So it could have done it a couple of times, right? Could have done it a couple of times, but it has to be at least once. Okay, that's what that means. You're going to have at least 1 0. Okay? All right. So in words, this is what it says. So if f is a polynomial function, the intermediate value theorem states that if f of A and f of B have opposite signs, which we saw that, this is positive, this is negative, then there exists at least one value C. And remember, it said at least one. It could have gone more than once, but at least one value C for between A and B for which f of C equals 0. That's what that says. So that's the intermediate value theorem. Now, how do you use it? How are we going to use it in here? So it's used quite often in calculus, but how are we going to use it in our course today? All right, so let's look at this example. All right, so here's the first example. Show that there is a 0 in the interval 0 to 1 for this function. All right, so in the interval 0 to 1, you want to show that there's a 0 here. So you want to show that when x is 0 and when x is 1, that the graph's going to cross the x-axis, because that's what we mean by a 0, the x-intercept. And so we're going to use the intermediate value theorem. So let's use the intermediate value theorem. So the first thing we're going to do is, so here's your solution. So you're going to find f of 0. So let's find f of 0. So f of 0 would be 0 cubed minus 3 times 0 plus 1. And so that's 0 minus 0 plus 1, which is 1. So f of 0 is equal to 1. Okay? Now let's find f of 1. F of 1 would be 1 cubed minus 3 times 1 plus 1. So that's 1 cubed is 1, 3 times 1 is 3, so that's 1 minus 3 plus 1, which is a negative 1. So f of 1 is a negative 1. Notice in the interval, just to show you real quick, so here's 0 and here's 1, right? 0 and 1. Oops, sorry, 0 and 1. So f of 0 is 1 right here. So there's the point. And then f of 1 is negative 1. So in that interval, you're going to have at least 1, 0. That's what this says. So you have shown that there's at least 1, 0 in that interval. Okay? So I use the intermediate value theorem to show that there is a 0 in the interval from 0 to 1. And that's going to be whatever that C is right there. All right, so that's the intermediate value theorem. Okay, so f of 0 is 1. So my y, when x is 0, my y value is positive. When x is 1, my y value is negative. So that means that according to the intermediate value theorem, there's got to be at least 1, 0. That's what you found. Okay, so you've shown that there's a 0 in that interval by finding those y values. Notice the y values are opposite signs. All right, so that's the first example. All right, let's go to number 2. So I'll use the intermediate value theorem to show there's a root. Remember, root means the same thing as 0, x-intercept, and the interval 1 to 2 for this function. So basically what they're saying is this. If you look at the interval 1 to 2, then you want to use you want to use the intermediate value theorem to show that there's at least one x-intercept, 1, 0. Okay, so let's find out what the y value is when x is 1, and let's find out what the y value is when x is 2. All right, so let's find f of 1. So f of 1 is going to equal 1 to the 4th plus 1 minus 3. Well, 1 to the 4th is 1. 1 plus 1 minus 3 is a negative 1. So f of 1 equals negative 1. Then f of 2, so we found f of 1. Now let's find f of 2. So f of 1 is negative 1, so that's down here. Okay? And then let's find f of 2. So f of 2 would be 2 to the 4th plus 2 minus 3. Well, 2 to the, So 2 to the 4th, 2 times 2 times 2 times 2. So that's going to be what? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Plus 2 minus 3. So that's 18 minus 3, which is what, 15? So f of 2 equals 15. So that's going to be up here somewhere. So notice that since this is a polynomial function, I have to have at least 1, 0 in here, right? So I've shown by the intermediate value theorem that there is a root, at least one of them, in that interval. So there's at least one c where my function is equal to 0. So that's what the intermediate value theorem says. Okay, so problem number 3 says this. Given the polynomial function that you see below, 4x cubed minus 6x squared plus 3x minus 2, what is the smallest positive integer a such that the intermediate value theorem guarantees a 0 exists between 1 and a? So basically what they're saying is this. So if you look at the x and y axis, let's say, and let's say this is 1, all right? So between 1 and some number a right here, what is the smallest integer a? Notice it says positive integer. Smallest positive integer a such that the intermediate value theorem says that the graph will cross the x-axis between 1 and a. So you're trying to find this a right there. Okay? So the best thing to do is this. So here's the approach you would take. You would start out with 1, find out what f of 1 is. So let's find f of 1. So find f of 1. So when I substitute 1 into x, I get 4 times 1 cubed minus 6 times 1 squared plus 3 times 1 minus 2. So 1 cubed is 1, 1 times 4 is 4, 1 squared is 1, 1 times a negative 6 is a negative 6, 3 times 1 is 3, and then minus 2. So 4 minus 6 is a negative 2, so I have negative 2 plus 3 minus 2, right? And then a negative 2 plus 3 is 1, and then 1 minus 2 is a negative 1. So f of 1 is equal to a negative 1. So I get some point down here, correct? So I want to find the smallest positive integer that's going to, see f of 1 is negative, right? So I want to find the next integer. I want to find the smallest integer so that the y value is positive. So now I want the y value to be positive. I found f of 1 to be negative. So f of 1 is negative. Okay, so f of 1 is negative. So now I want to find the smallest integer where f of a is positive. So let's go to the next integer. So the next integer is 2. After 1, it's 2. So let's see what f of 2 is. So f of 2 would be 4 times 2 cubed minus 6 times 2 squared plus 3 times 2 minus 2. So 2 cubed is 8. 8 times 4 is 32. 2 squared is 4. 4 times a negative 6 is a negative 24. 3 times 2 is 6, and then minus 2. 32 minus 24 is what? 8. 8 plus 6 minus 2. 8 plus 6 is 14. 14 minus 2 is 12. So I found f of 2 to equal 12. And so that means that that number here is here. So that means the smallest number for a is 2. So when a is 2, it is guaranteed that there's going to be at least one 0 in the interval from 1 to 2. So the answer is 2. So to answer the question, you would say this. You would say the smallest integer a that guarantees a 0 between 1 and a is when a equals 2. Okay? All right, so that was that one. Let's look at another one. All right, so let's look at this one. So this time we have this function, f of x equals x cubed minus x squared plus x minus 2. And then the question is, what is the smallest positive integer a such that the intermediate value theorem guarantees a 0 exists between 0 and a? So in other words, here's where x is 0, and then I want to know what is that smallest positive integer a, so that way you're going to get the graph's going to cross the x-axis. Okay, the smallest positive integer. All right, so first of all, let's find out what f of 0 is. So f of 0 will be, and so wherever you see the variable x, you're going to substitute 0. So you have, remember, f of x is x cubed minus x squared plus x minus 2. All right, so I get 0 cubed minus 0 squared plus 0 minus 2. So 0 cubed plus 0 squared plus 0 minus 2 is just a negative 2. So f of 0 is equal to negative 2. So that means when f is 0, I get this point right here. So now what I want to know is this. I want to find the smallest positive integer a, so that way my y value is positive. So my y value is positive. So here my y value is negative. I want to find an a where my y value is positive, but the smallest integer. So the next thing you do is go to the next integer, f of 1. So let's see what we get when you do f of 1. So f of 1 is 1 cubed minus 1 squared plus 1 minus 2. So 1 cubed is 1, 1 squared is 1, plus 1 minus 2. 1 minus 1 is 0, 0 plus 1 is 1, so all this is 1, and 1 minus 2 is a negative 1. So I found f of 1 to be negative 1. So f of 1 is negative 1. So a is not 1. So now I go to the next integer. The next integer is 2. So I get 2 cubed minus 2 squared plus 2 minus 2. So 2 cubed is 8, right? 2 squared is 4 plus 2 minus 2. 8 minus 4 is 4. 4 plus 2 minus 2. 4 plus 2 is 6. 6 minus 2 is 4. I found it. F of 2 is 4. So what that means is that a must equal 2, and that's that smallest. When a is 2, that's the smallest integer where you can get a positive value for a. And so therefore, whatever the graph looks like, you'll get a 0. So it'll be some number c in that interval from 0 to a where the graph's going to cross the x-axis. So the answer is 2. So the smallest a that guarantees, the smallest a that guarantees a 0 is when a equal 2. Okay? All right, so that was that example. All right, so that's number 4. Okay, so number 5 says this. Given the following table of values of the polynomial function f of x, what is the minimum number of zeros of this function that are guaranteed by the intermediate value theorem? So probably the best thing to do is to look at this in terms of the coordinate plane. So my x is 1, 2, 3, 4, 5, 6, right? So 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. And the best thing to do is just to actually plot those points. So when x is 1, my y value is 7. The f of x is y. My y value is 7. So that is in the first quadrant. Okay? When x is 2, my y value is negative. When x is 3, my y value is positive 4, right? So somewhere around here, let's say. It doesn't have to be accurate. When x is 4, I get a y value of negative 2. When x is 5, I get a y value of 7. When x is 6, I get a y value of 10. Okay? So between the interval 1 to 6, between that interval 1 to 6, I know, remember this is a polynomial function, so I know that my graph has to at least cross the x-axis once. It could cross it more than once, but at least once. So that's the idea that minimum. What's the minimum? So I know it has to cross at least once here. And then notice it's negative here, positive here, so it's got to cross at least once here as well, right? And then over here, it's got to cross at least once as well here. And so these are zeros. This is a 0. Whatever this is, that's a 0. Whatever that is, that's a 0. And then over here as well, that's another 0. And then notice that from 5 to 6, it doesn't cross because in both cases, well, let me rephrase that. So I know that from 5 to 6, when x is 5 is positive, when x is 6 is positive, it may still cross, but I don't know that. So I don't know whether it crosses or not because I haven't found any of these other values. So I don't know yet. But I do know that the minimum number would be 1, 2, 3, 4, right? So the minimum number of zeros that are guaranteed by the intermediate value theorem is 4. There could be more. That could be more. It could go here and all of a sudden come back up, right? But that's the minimum. So based on what I know, based on what we know, where these are opposite signs, these are opposite signs, these are opposite signs, these are opposite signs, I know that it's got to cross the x-axis. It could cross it more than once. It definitely could, because all you know is just these two. You don't know anything else here. It could cross more than once, more than once, more than once, but you definitely know that since this is positive and this is negative, you have to have at least one here, at least one here, at least one here, at least one here, and you don't have enough information to even say that it does this. It may not, but the minimum number is 1, 2, 3, 4. So the answer is 4. So the minimum number of zeros of f of x is 4. That you know. You know it has to be at least 4. It could be a lot more than 4, but you know it has to be at least 4. So that's what that says. All right, so let's look at the last one. So this will be the last one we're going to do on the intermediate value theorem. So it says, which of the following polynomial functions is guaranteed by the intermediate value theorem to have at least one zero in the interval between the interval -4 and -1? So for each of these, you have to determine what f of -4 is and what f of -1 is. And remember the intermediate value theorem, just like in the previous example, says that if the y value is positive in one case and the y value is negative in the other, then there's got to be at least one zero, at least one place where the graph crosses the x-axis. Okay, so that's what that means. So let's go ahead and find, for each of these, we're going to find f of -4, f of -1. All right, so let's do part A. So part A, so here's the work. For part A, you have f of x equal -x to the 5th plus x cubed plus 1. So f of -4, so wherever we see the value x, I'm going to substitute -4. So I get the opposite of a -4 to the 5th plus a -4 cubed plus 1. So using a calculator, a negative 4 raised to the 5th, so parentheses negative 4, let me see if I can get the glare out. So parentheses negative 4 closed raised to the 5th equal, and remember we're taking the opposite of that though, so it's going to be a positive 1024. So this is a positive 1024. Negative 4 cubed, so parentheses negative 4 cubed will be a negative 64, and then plus 1. But I want you to notice something. 1024 minus 64 plus 1 is positive, right? All right, so let's just go ahead and figure it out, though. 124 minus 64 plus 1 equals 961. So f of negative 4 is equal to 961. All right, so that's positive. So let's see what happens when x is negative 1. So let's find f of negative 1. So f of negative 1 will be negative 1 in parentheses to the 5th, but I'm taking the opposite of that. That's what you see here, plus a negative 1 to the 3rd plus 1. Negative 1 to the 5th is a negative 1, and the opposite of a negative 1 is a positive 1. Negative 1 to the 3rd is a negative 1, and then plus 1. So 1 minus 1 is 0. 0 plus 1 is 1. So f of negative 1 is positive. So notice those are both positives, right? So the intermediate value theorem does not guarantee there's at least one 0 here. Okay, so there's no guarantee since f of negative 4 and f of negative 1 are both positive. The intermediate value theorem, I'll call it IVT, intermediate value theorem, does not guarantee there's at least one 0. At least one 0 in the interval negative 4 to negative 1. Okay? So it does not guarantee. Remember, in order to guarantee, one has to be positive, the other one has to be negative. All right, so that's letter B, letter A. Now let's do B. Let's see what happens when we do B. All right, so B is this. So our function is f of x equal negative 2x cubed plus 6x. And remember, the interval is negative 4 to negative 1. And it doesn't matter whether they're brackets or parentheses. Sometimes you'll see textbooks use brackets for the interval. Sometimes they'll be parentheses. Does not matter. All right, so let's find f of negative 4. So f of negative 4 would be negative 2 times negative 4 cubed plus 6 times negative 4. So let's see what that is. So negative 4 cubed times a negative 2. All right, so negative 2. So negative 2 times, in parentheses, a negative 4, close the parentheses, cubed, right? And so that's positive 128. 6 times a negative 24 is a negative 24. So 128 minus 24 is 104. So f of negative 4 is 104. Now let's find f of negative 1. F of negative 1 will be negative 2 times negative 1 cubed. So wherever we see the variable x, I'm substituting negative 1. Plus 6 times negative 1. Well, negative 1 cubed is a negative 1. A negative 1 times a negative 2 is a positive 2. 6 times negative 1 is a negative 6. And 2 times 2 minus 6 is a negative 4. So f of negative 1 is a negative 4. So notice my y value at negative 4 is positive, and my y value at negative 1 is negative. So the intermediate value theorem will guarantee that there's at least one 0. So since make sure you understand this, okay? So here's negative 4, negative 1, right? So when x is negative 4, I get a positive y value. When x is negative 1, I get a negative y value. So the intermediate value theorem says you have to have at least one 0. So since f of negative 4 equal 104 and f of negative 1 equals a negative 4, the intermediate value theorem guarantees that there is at least one 0 between negative 4, and negative 1. Okay? Oops, forgot to put the negative 1. So between negative 4 and negative 1. All right, so that was B. So let's do C. So here's C. So in C, we have this function, f of x is equal to negative 4x cubed plus 5x squared plus 2x plus 6. So I want to see if the intermediate value theorem will guarantee a 0 between negative 4 and negative 1. So we got to find the y value for each of those points here, negative 4 and negative 1. So f of negative 4 will be negative 4 times negative 4 cubed plus 5 times negative 4 squared plus 2 times negative 4 plus 6. All right, so let's go ahead and figure out this right here. So we have negative 4 times negative 4 cubed. Which, by the way, is negative 4 to the 4th power, right? Because both of those are the same number, negative 4. But I'm just going to write out what I see. So negative 4 times negative 4 parentheses cubed equals positive 256. A negative 4 squared is 16. 5 times 16 equals 80. And then minus 8, and then plus 6. So 256 plus 80 minus 8 plus 6 equals 334. So f of negative 4 is positive, right? So f of negative 4 is positive. So I need f of negative 1 to be negative if the intermediate value theorem is going to guarantee there be a 0. So let's see if f of negative 1 is negative. So I get negative 4 times negative 1 cubed plus 5 times negative 1 squared plus 2 times negative 1 plus 6. Negative 1 cubed is negative. Negative times negative 1 times a negative 4 is a positive 4. Negative 1 squared is positive. Positive 1. 1 times 5 is 5. 2 times negative 1 is a negative 2, and then plus 6. So 4 plus 5 is 9. 9 minus 2 is 7. 7 plus 6 is 13. So f of negative 1 equals 13. Since both signs are positive, since f of negative 4 and f of negative 1 have the same sign, the intermediate value theorem does not guarantee that f of x has a 0 between negative 4 and negative 1. All right. And then finally, let's look at D. So D, we have this function for D. We have f of x equals x cubed plus 4x squared plus 3x minus 1. And again, we're looking at the interval negative 4 to negative 1. All right, so we got to find f of negative 4. So that's going to be a negative 4 cubed plus 4 times a negative 4 squared plus 3 times a negative 4 minus 1. Negative 4 cubed, so negative 4 cubed, use your calculator, is a negative 64. Negative 4 squared is 16. 16 times 4 is also 64, right? And then minus 12 minus 1. So that's 0 right here. And then negative 12 and negative 1 is a negative 13. So f of negative 4 equals negative 13. Now let's find f of negative 1. So f of negative 1, wherever we see the variable x, I'm going to substitute negative 1. So you get negative 1 cubed plus 4 times negative 1 squared plus 3 times negative 1 minus 1. Well, negative 1 cubed is a negative 1. Negative 1 squared is 1. 1 times 4 is 4. 3 times negative 1 is a negative 3, and then minus 1. Negative 1 plus 4 is 3. 3 minus 3 minus 1. 3 minus 3 is 0. Subtract 1 is a negative 1. So f of negative 1 is negative 1. So notice that both of those y values are negative. So since f of negative 4 and f of negative 1 have the same sign, the intermediate value theorem does not guarantee, I mean, there may be, right, but it doesn't guarantee that there is a 0 between, in the interval, negative 4 to negative 1. All right, now it doesn't mean there isn't any, it just doesn't guarantee that there is one. Okay, based on the interval you're using. Does not guarantee there is one. There could be one, but doesn't guarantee there is one. All right, so that is, so quite a bit of work there. I know that this, the intermediate value theorem involves quite a bit of information. But that is the topic on the intermediate value theorem. I can go ahead and find the original page. So here's the original page. So that was the lesson on the intermediate value theorem.